extreme climate changes continued, putting life on a path to new evolutional stages for survival. Life evolved with prokaryotes and eukaryotes living together as ever larger symbiotic organisms, compensating for each other's shortcomings and thriving as a whole. This greatly expanded the possibilities for forms of life. Life forms grew to 1 million times the size of eukaryotes and 1 trillion times the size of prokaryotes. The appearance of multicellular life was a critical leap for evolution. Another glaciation period came, and life suffered a mass extinction. With time, this glaciation also passed, and the global climate gradually warmed. Phosphorus and other materials essential for life circulated through the climate system and accumulated in the oceans. The animals of the Ediacaran period appeared at this time. Dickinsonia are iconic among the Ediacaran fauna. Some grew to over 1 meter in length. They were soft-bodied creatures with no shell or skeleton. They probably lived in warm, shallow marine environments around the Rodinia supercontinent. The supply of nutrients from the land was ever increasing, as was atmospheric oxygen. The amount of ferrous iron in the oceans increased. The ferrous iron oxidized, once again creating large bands of iron. Phosphorus and calcium levels in the ocean increased. Life evolved to use these elements, becoming animals with bones and shells. For example, the calcium helped protect Microdictyon from other animals. Their bodies used calcium to form a covering of hard scales. Life evolves to survive, making use of the elements in its environment. And the Earth's environment alters the shapes of life. The Earth entered another period of climactic instability. The Earth alternated between periods of extreme heat and extreme cold for tens of millions of years. These severe changes killed off the Ediacaran fauna. Nevertheless, new species were about to appear. Radiation from inside the Earth plays a significant role in the evolution of life. A continental rift is a place where a continent breaks open to expose erupting magma and radioactive elements. Radiation hastens the creation of new species and new branches in the tree of life. This is stem evolution, creating new species at continental rifts. Life evolved separately on each small continent. When small continents recombined, their life forms crossbred. Different crossbreedings created new forms of life. Variation thrived. This is crown evolution. Continental collisions created more diverse surface environments. Bays and gulfs on large continents were especially well supplied with nutrients from upstream. Making use of these nutrients, Cambrian-era life forms diversified much more quickly. The Cambrian explosion created some 35 new phyla. These phyla became the foundation for the types of plants and animals we see today. There are three main ways that life evolved. Mass extinctions that eradicated many species. Stem evolution that hastened genetic mutations when continents broke apart. And crown evolution that hastened biodiversification when continents collided. So, the evolution of life is inextricably linked to environmental changes due to universal factors and continents assembling together and breaking apart.